Now I'm gonna present my assignment 4. First, I'm gonna import some libraries that are necessary for my assignment, like Matplot, TensorFlow, Keras, and NumPy. The dataset I'm using is CFA 100, um, which consists of 60,000 color images in total, which 500 images in each of 100 different classes. The image are 30 multiple 30 pixel in size and are divided into 50 training images and 10 50 thousand training images and 10,000 test images. The application of CFAR 100 include images recognition, uh, object detection, and deep learning research. I load the CFAR 100 dataset by method load data and then divide them into train images, train labels, test images, test label, and then I normalize them to range 0 to 1 by divided by 255. You can see here the shape of each of them, like the shape of training images is 50,000 32 32 pixel, and this is the shape of test images, and also showing you the digital content of train images file by the calling the plot method. Okay. Now I create the model with Keras sequential. I add some layer to the model like conv22d, conv2d, matplotlib 2d, and this. And then I compile the model with the optimizer Adam and the loss function spare categorical Gaussian trophy. This is commonly used for multi-class classification problem. And from logic, argument is set to true, indicating that the model output does not go through the short math activation function before being fed into the loss function. The metric set to accuracy argument specify the metric that will be used to evaluate the performance of the model during the training and evaluation. And then I call in a summary to see the overall of the model. As you can see here, this layer, the output shape, and the param. The total param is over 100,000. And then I create a custom callback class. This class will be called during the training. And then I train the model with train images and train labels. I set the epoch to 50, which is the number of times the entire dataset should be iterated during the training process. And this is the result. and you can see here there is overfitting. You can see the accuracy rating valuation is increased to from 27% to 36% in first 20 epoch, but then it's decreased to just 31% percent in the 50 epoch. To make it more clearly, I'm gonna show the graph. Show the graph for accuracy, for training accuracy and validation accuracy. It's clearly that the training accuracy is increased from about 22% to 70%. Meanwhile, the validation accuracy just increased in first 10 epoch from 27% to 37%, and then it's decreased to just 31% in the epoch 50. To prevent the overfitting, I'm gonna add before that I'm gonna show the training loss and validation loss graph. You can see the training loss, it decreased from 3 to 1. Meanwhile, the validation loss is decreased in first 10 epoch, and then it's increased to 4.5. To prevent the overfitting, I'm gonna add a layer dropout 0.5. The dropout can reduce the complexity of the model and make it more generalizable. In this time, I reduced the epoch to 30, and you can see the result. The accuracy training is increased, and also the accuracy validation also increased. To show in the graph, you can see the training accuracy compared to the last graph is almost quite the same, but the validation accuracy in this graph is decreased, but in this new graph it is still increased. It's from the 10% to almost 35%, and it's always increase. About the loss, training loss and validation loss. In this graph, the validation loss is now decreasing. Validation loss now in decreasing. Meanwhile, in the last graph is increasing. That means the overfitting is now gone.